Hi, and welcome to my poster presentation. I will first give a small introduction, and then we will further zoom into the different results sections. So over the past few years, we have been studying Acinar dedifferentiation as a very important first step in pancreatic tumor formation. And we were wondering specifically why duct-like dedifferentiated Acinar cells are so different from naive duct cells in terms of tumor formation. So what we did first was to transcriptionally profile these two cell populations isolated from human healthy donors. And we found enrichment of pathways in cancer in the differentiated Acinar cells with prominence of MECOM, a transcription factor that was not yet described in the context of Acinar cell dedifferentiation. So we confirmed by RNA in situ hybridization the expression of MECOM in dedifferentiated Acinar cells on tissue sections of embryonic mouse pancreas, but also acute and chronic pancreatitis. Within dedifferentiated Acinar cells over time in culture, we saw a strong correlation with SOX9, an important transcription factor indispensable for pancreatic tumor formation, but also in vivo, when we knock down SOX9 in Acinar cells after serine-induced acute pancreatitis, we see a significant decrease in MECOM expression. Moreover, luciferase reporter assay pointed at direct binding of SOX9 to the MECOM enhancer. All of this together showing that SOX9 directly regulates MECOM expression in dedifferentiated Acinar cells. To further study the role of MECOM in Acinar dedifferentiation, we knocked it down using CRISPR-Cas9 into 666 cells. We immediately observed a clear phenotype in the culture dish where the prominent dome formation was significantly decreased in the knockdown cells. Also, the absolute amount of total cells and the cell viability decreased after seeking. RNA-seq pointed at an impairment in cell-cell adhesion, which might lead to an increase in cell death and a decrease in cell viability through ERK signaling pathway. This phenotype became also more apparent when we isolated Acinar cells from knockout mice, where we saw that after 4 days of culture, we saw a significant decrease in cluster diameter and CK19 positive cells, but an increase in cleaved caspase 3 cells. And this became even more apparent when we induced an acute pancreatitis in vivo, where we saw that there was at the peak of inflammation, a significant increase in cleaved caspase 3 cells that led to a higher ratio of interacinar spaces filled with immune infiltrates, but not so much with collagen. So in conclusion, we transcriptionally profiled dedifferentiated Acinar cells and duct cells, and this led to further insights in the role of MECOM that suppressed Acinar cell death by permitting Acinar cell dedifferentiation. And by this, I would like to thank you for your attention and looking at my poster presentation.